Let's discuss the map interface. The map is a little bit different. The other interfaces in the collection interfaces inherit from the collection interface, but not map, because map works a bit differently. Where the other interfaces were made for storing multiple values, map is made for storing key value pairs. Multiple ones, of course, but key value pairs instead of single values. The map interface is also a core interface in the collection framework, and it's used to store the key value pairs. A map allows you to look up values based on a key. The map interface provides methods for adding, retrieving, and removing elements from the map. And as you can imagine, adding key value pairs is a bit different than adding a single element. That's why it's a separate interface. Let's see map for ourselves in IntelliJ. Alright, let's start by creating a map. So, since map has key value pairs, I need to specify two generics. So in this case, I'm going to specify a string and an integer. And of course, I need to import map as well. It's in the Java util library. So, okay, I'm going to call this one my name ages map. And then I'm going to say new hash map. Again, map is an interface, so I cannot instantiate this. Hash map is an implementation, and I can instantiate that one. So I'm not going to add, I'm going to put. And I'm going to specify a string, in this case my own name, and my current age. Okay. And let's do this again. Put, and this time I'm going to do another one. And let's add a third one as well. And 625. Okay. So, as you can see, it takes two generics. And of course, I must make sure that when I put it, that the generic match. So I can't, for example, say 2 and then high, because the order is string integer, not the other way around. You can also not add anything else, because it's going to check the key must be a string and the value must be an integer. We can get values out by their key. So, for example, let me first print this map, but then if I want to get one value out, for example, my age, I would go ahead and say get, and then insert my name, because that's now the key to get it. Okay, let me run this and show you what the output looks like. As you can see, it prints the values on the map as key value pairs separated by the equal sign. And then when I go get the value from Micah, it prints 31. So that makes sense, because I associated the key Micah with the value 31. So since map is a bit different, some things work a bit differently. For example, iterating over it works a little bit differently, because I can't just really iterate over my map. I need to be a bit more specific. So what I could say, that I'm going to iterate over all the values. That would look like this. The values are integers, so I'd have to say integer I, for example, and then go name ages map dot values. And then I could go ahead and print all the values. As you can see, map is also unordered. They're not in the order that I stored them in. It has to do with the hash map. Spare the details for now. So what I could also do, I could also loop over the keys. And this would give me back a key set, and I could print all the keys. And with the keys, I actually have access to the values as well. So I could go ahead and say something like this. Dot get, and then insert s. So that's also something that can be done. Let me show you the output. And as you can see, we get the keys and the corresponding values. Then there's one last way to loop. So in this case, I'm going to be looping over the entry set. So here's how that's done. It will be an entry, which is on the map interface, and I'll have to specify the key and the value, or at least their types. And then, well, let's just call this entry for now, and then go name ages map dot entry set. And this is going to return key value pairs. And I can go ahead and use these, well, to just work with the keys. So the first one is going to be of type string. So I could go ahead and just print it here. I just could say entry dot get key. And the second one is of type integer, which I can also just print. But you can see it actually knows the types because of the generics we specified. Alright, so there's more that we can do with map. For example, we could also go ahead and remove items. So if I grab the name age map and I'm going to be removing, I would have to use the key for that, so the name. So in this case, I'm going to remove Lola. But I could also update something. Say it has been my birthday and I turned 32, which would be a logical new age after 31. I go ahead and I just do put and then the same key again, and now it's just going to update Micah to be 32, since the keys in the map must be unique. Well, think about that for a second. That's not too weird. I'm actually not printing the new map just yet. Let me add that too. So it's not too weird that the keys must be unique, since we use the key to retrieve the value. That means that without the key, we couldn't get the value. And if there's a duplicate key, there would be an ambiguous value. So that's not possible. So the keys, they must be unique. And it just assumes when you're going to put something with the same key that you want to override the value that you provided. So in this new version of the map, you can see that we now have 2 left because we removed Lola and Micah, her age, got updated. Well, that's actually it for the map interface in the collection framework. We can use it to store the key value pairs. And this concludes our series on the Java collection framework. Before you move on to the next topic, make sure to get some practice. You'll use these a lot in real life as well.